Hi, so we're going to continue our discussion of molecular compounds, molecules, covalent compounds. Those three things all really mean the same thing. We're going to start by looking at revisiting what we call the diatomic elements. We talked about the halogens when we did that back in the periodic table, chapter 6. We talked about the halogens being diatomic, which meant that all of them need to be bonded to another atom of itself to be stable. So basically, you can never just, if I call up a chemical company and said, send me some bromine, it's not bromine atoms. It's always two atoms of bromine bonded together. And there's actually 7 of them. They're all the halogens. So remember, the halogens are fluorine, chlorine, bromine, and iodine. And then there are the 3 others. And these guys are the ones that are right at the top of the periodic table. Hydrogen, nitrogen, and oxygen. They don't all just have a single covalent bond in the middle. You can see that nitrogen actually has a triple bond in the middle. Oxygen, it says inadequate. It's basically a double bond in the middle. There's some other stuff going on that we don't talk about in first year chem. That's why this says inadequate. We're going to call it a double bond and sort of call it a day. So you will need to have these, I don't want to say memorized, but in like a future chapter, if I'm asking you to write a balanced chemical equation and in it I say nitrogen gas, you need to know that nitrogen gas is N2. Whereas if I say helium gas or argon gas, that's just AR, not AR2. So how do we remember it? Well, there are 7 of them. And if you look at a periodic table, the nitrogen, oxygen, fluorine, chlorine, bromine, and iodine kind of make a number 7 on the periodic table. And then if you think about that and look at the elements that make that up, there's really only 6 of them. And so I always think of it as like it's pointing you, say like, hey, look over here, to like remember that there's hydrogen there. Remember, we also talked about how hydrogen, there's a few reasons why hydrogen could belong on top of the halogens. One of them is that it is also diatomic. Another way to remember the diatomic elements is the mnemonic HON family. So HON, hydrogen, oxygen, nitrogen, and then the F in family reminds you of fluorine. And family and group are 2 different ways to discuss columns or to just name columns on the periodic table. So we talk about this now because the diatomic gases are really good examples of molecules where it's a finite group of 2 atoms that are bonded together. And a molecular formula is a formula that gives the actual number of atoms in that molecule. It's different than the ionic formula or formula unit that we used for ionic compounds. For ionic compounds, it was the lowest whole number ratio of those ions in the ionic compound. And that's not what a molecular formula is. Molecular formula is the actual number of them. And in this picture, you'll see a number of just different ways that we can represent molecules. So most of the time, we're going to represent molecules with their molecular formula. Like when we do balanced chemical equations or we start to do math conversions with them. When we're talking about, molecules of NH3 to moles of NH3, doing those type of conversions. But there's other ways that we can represent that molecule that really get into the shape of the molecule. And you can see that in the ball and stick model, in the space filling model, a little bit with the structural formula or the perspective drawing, that we get a little bit of the shape of the molecule. Shape of molecules is going to be important when we start discussing properties, because the shape of the molecule helps determine whether the molecule is polar or nonpolar. And polar or nonpolar helps determine things like melting point, boiling point, solubility in water. So the shape is eventually going to be really important to us. And so this is just, as we go through this chapter and we see these sort of space-filling molecules, these are just some of the models for some common molecules that you may know. We have very specific colors that we use for elements. So hydrogen is always represented with white. Oxygen is always represented in red for like fire. Carbon is always black. If you think of like soot or coal or petroleum, right? Those are black. So carbon is black. The one that's not pictured here is nitrogen. Nitrogen is, we saw this earlier, is often blue. So this is just a quick sort of overview of some ways that you may see molecules expressed.